We beat all the Tesla Roadsters. The car that we built in my driveway was faster than Tesla Roadsters. And so we had a whole team of people that were building that, working on that, and having a grand old time with it.
If you could future-proof one aspect of or one component of today's energy infrastructure or architecture, what would it be?
Oh, it would definitely be the battery management system. The key job of the battery management system is to prevent lithium battery fires. That is why we exist. Here's the truth of it. Existing functional safety systems and commissioning systems aren't set up to look for systems like this. Like there is not a structure in the industry for looking for electronic backdoors.
I want you to take me back to the beginning of Nuvation. What problem in those early days as a founder and entrepreneur were you trying to solve when you first founded the company?
Sure. So Nuvation started as an engineering services company. And there I was graduating from the University of Waterloo, just a few miles from where I'm sitting right now. And I was an electrical engineer with a brandly minted degree. I knew I wanted to start a company. I knew I ultimately wanted it to be a product company, but I wanted to start it as a services company in order to get, initial contracts. And so there I was, a new grad, making phone calls, trying to figure out how to run an engineering services company. And interesting enough, where I found most of my traction was phone calls into Silicon Valley.
Oh, wow.
And so we just got in like a few weeks kind of time frame. And I was like, you know what? The right place to found this company is Silicon Valley. So packed as many suitcases as we could, flew down to San Jose, knocked on the front door of a friend's house, and said, hey, I don't have any money, but I'm starting a company. Can I sleep on your couch for a while? He looked at me and he was like, Michael, wow, what's it been, like 5 years since I saw you last? I was like, yeah, I know, it's been a while. But is your couch available? And he's like, sure.
For how long?
That was like a couple months kind of time frame. And inside of that, we figured out how to close our first contract. Our first contract was an electronics design for a GPS for terminal navigation.
Oh, wow.
And so we figured out how to found a company, drove to Nevada, signed all the legal documents to found a company. And
in Nevada?
Yep. Yeah, well, because I walked out of that sales call and I said, okay, I got the deal. They said they need a EIN number to get started. Do we have one of those? And my partner was like, yes, I know how to get one of those. We have to found a company, and apparently we're supposed to do that in either Delaware or Nevada. It's like, I'm Canadian. I don't know where those things are. He's like, well, we can drive to Nevada, but we'd have to fly to Delaware. Great, Nevada it is.
Let's go.
So we drove 10 hours to Nevada.
Oh my God.
Founded the company, drove back because we didn't have any money, right? So we couldn't afford flights and stuff like that.
And this is pre like functional internet too. You couldn't just jump on inkfile.com.
Nope, didn't have any of that kind of stuff. So it was hard to get a cell phone. But anyway, so we figured that all out. And in the early roots of Nuvation, there's many founding stories there of what it was like to basically figure out how to run a business.
Yeah.
And then if we fast forward to Nuvation as it is today, in 2008, we made a declaration that we said, you know what, the deterministic future in front of us is the world's going to be solar, wind, energy storage, and electric vehicles.
Yeah.
And if you look back to 2008, that was pretty futuristic,
No doubt.
to say that at that time.
Yeah.
And so we started, building products inside of that.
Michael, it sounds like you went straight from uni to running your own thing. Did you ever have anything that sort of resembled a traditional job or any sort of training in that regard?
I did. And so one of the best things about University of Waterloo, huge promoter for Waterloo, is they have a phenomenal co-op program. And so what they do is it's a 4-year degree, but they split it up and you do 4 months of work and 4 months of school. And so I had 6 work terms inside of my electrical engineering degree. So I graduated with 2 years of real life work experience. And so when I graduated, I had 3 job offers from employers who had already worked with me. I turned them all down and founded Nuvation. So to dive into the story of how we went from Nuvation Engineering to Nuvation Energy, we made this declaration in 2008. We think the future is going to be, energy storage, electric vehicles. Right. I said, okay, what do we do with that information? What products do we build inside of that? So what we did was, most people would have ran off and done like market studies or something like that. In our style, we have what we call Nuvation Garage, and it's part of our kind of secret sauce of success of a company,
Yeah.
where we do fun projects after hours. And it tends to be that Nuvation picks up the parts cost for it, but the engineers donate their time because we're working on cool stuff.
Yeah.
And so inside Innovation Garage, we built a race car electric vehicle.
Oh, wow.
And this was back in 2008. It competed in the Automotive X Prize. And this was back in a time when people thought of electric cars. They thought of like golf carts.
Right.
And we built this three-wheeled E-Rex. We took a T-Rex gas car, took out the gas engine, replaced it all with a battery and electric engine. And then we raced that. And it was fun. I remember doing like Laguna Racetrack. There's like 20 electric cars racing there, including 5 Roadsters. We took third place. We beat all the Tesla Roadsters. The car that we built in my driveway was faster than Tesla Roadsters.
Love it.
And so we had a whole team of people that were building that, working on that, and having a grand old time with it. But behind that, really the business intention of doing that was to look at, okay, where in this industry is the problem solved? And where is this industry is there opportunity? And what we found inside of that was, okay, I can buy off the shelf motor inverters. There are lots of those around. I can buy motors. I can obviously buy battery cells. All those things are available for purchase. Where we couldn't just buy things was, number one, the battery management system. We couldn't find a good off the shelf third-party battery management system, so we made one. We couldn't find a high power, high voltage DC-DC converter, and we couldn't find a vehicle controller. And so inside of that E-Rex initiative, we made all 3 of those, made them to garage standards. So like just good enough for a one-off garage program.
Sure.
And the other side of that, we looked at that and said, okay, what do we think of these 3 products? Which has the best commercial value? And we picked the BMS as the thing that we felt had the best opportunity. And that's how Nuvation Energy got started. Market research through building.
You have to do a lot of interaction with customers, potential customers, folks that don't even know they want to be customers, to build a new product. And one of the things that I know Landmark teaches is to listen for what's not being said. Can you give us a sense of what you heard in that regard over the course of building the Nuvation battery management system and why this product is unique in the marketplace?
So we interviewed hundreds of customers before we built our commercial battery management system. And each customer would have their specific requirements of what they wanted in a battery management system. And what wasn't said was they wanted a configurable battery management system that could be used across a wide variety of applications. And we looked at the marketplace. What was there was all the other BMSs were fixed function. So they were built for, this is going to go in an electric vehicle of this specific chemistry, of this specific stack voltage. And it was all locked down. And so we actually built the world's first configurable, functionally safe battery management system. And we know we were first because we went to UL to be tested for UL 1973. And UL said, great, what's the stack voltage? What's the chemistry? What's the battery topology? And we said, that's all configurable. And UL said, how the heck do we possibly test for something to be safe if it's that configurable and that flexible? We're like, I don't have the answer to that. You guys are the functional safety testing guys. We're the electronics design guys. So, let's figure this out. And you all worked with us. It took about a year. And we actually had to invent a new process as to how to test functional safety for a configurable, functionally safe product.
Wow, that's fascinating.
Yep.
As a result, how is this product redirecting, as it were, the energy storage architecture? Is it providing more optionality? Like, what if I'm a battery developer or if I'm a OEM? How does this innovation in the technology improve my world in some way?
Yeah, so we primarily sell to system integrators, and the problem that we solve for a system integrator is we remove the cost of switching between battery manufacturers. So most of our customers tell us that one of the things they really like about our BMS is that we're effectively a battery device driver. And so you can, underneath our battery management system, put a wide range of chemistries and a wide range of battery manufacturers. And for us, it's identical hardware and just a different software configuration file.
I think we need to talk about how things are being done ordinarily, right? Like, absent a conversation with Nuvation, if I'm trying to develop projects, what are my options available for BMS?
Yeah, so most battery management
Status quo.
systems, status quo is most battery management systems are built as a fixed function BMS that is not
Mm.
configurable. It is built for a specific application.
Are they
And
built by the OEM battery manufacturers, or are they built by third parties like Nuvation?
so being built by third parties is a more recent trend. So Nuvation is one of few battery management systems that is a third party utility scale battery management system. Most BMSs are built in house. So if you look at the big players like Tesla and Fluence and so forth, they have their own in-house BMS programs, and that's because they've been doing this for 15 more years. And so when they went to design their first energy storage system, they had to make their own BMS because there were not BMSs available for purchase. So they had to do a vertically integrated approach. I often do an analogy to Henry Ford. So when he built the first Model T, he had to make everything because there was no automotive supply chain. So he had to make his own wiper blades, his own windows, his own tires, his own everything because there was no supply chain. But if you look at the automotive industry today, everything is highly specialized. So there are companies that just make engines, just make tires, just make door latches. So energy storage is doing the same thing. Energy storage is growing up as an industry. And people are finding that there's, by having specializations of expertise, you actually produce a end product that is better and cheaper because you have people that are experts at each individual thing. So we're basically taking a page from the automotive industry or any major industry where people specialize on what they are the best at.
I've seen a lot lately around things that we only had sort of had hypothesized. Obviously, a couple of about maybe 5 years ago, there was the whole Huawei situation around cybersecurity. It seems to me like the brains of the operation is the place where you want to make sure that you have control, so to speak. And I've seen numerous articles lately purporting that Asian and or Chinese Trojan horse access to solar plants and increasingly battery systems is a presumed concern around cybersecurity. How do you think at Nuvation about this topic of cybersecurity, given that probably gatekeeping the project itself is one of the big jobs of a BMS?
Yeah, cybersecurity has increasingly become a really important topic, and we do have a perspective on this. Most people, when they think of cybersecurity, they think of what I would call network security, and so they're thinking of firewalls, passwords, logins, authentication, those sort of things. And this is assuming that you've got some bad actor somewhere else, and they're hacking through traditional networks in order to try and get to an electronic device. We would put forward that at least as important inside of cybersecurity is supply chain security. And what that means is choosing electronic products that are from domestic or allied sources where you can trust that supply chain. And what we point out to people is that if you manage to access a device through some other wireless means, then you've ended around all that network security. A typical example I use on this is my Apple Watch. So this Apple Watch has, Wi-Fi, Bluetooth, but it also has satellite communication. And so we've proven as a society that a device this small can receive commands from a satellite. Well, there are foreign adversaries that definitely have satellites. And we know a battery management system is much larger than the size of an Apple Watch. So it is certainly engineering possible to end around all traditional network security and send commands directly to an electronic device in the field.
That's terrifying.
It is terrifying. This is highly alarming, and this is
how many
assets
would you wager are potentially susceptible to this? If you had to guess, how much exposure do you feel like the industry potentially has to this kind of espionage, if you will?
It's a real risk. Like there was just that Reuters article a few weeks ago where there were undocumented wireless devices found in an overseas energy storage system. And to your question, like we've got hundreds or even thousands of energy storage systems installed across the U.S. And the risk is that these things could be accessed and shut down.
It amazes me that things like this get past commissioning at all, right? Like this seems like a simple checklist. Is everything I ordered in the box and only everything I ordered? And I feel like in some ways this is a case of the industry trying to drive to the lowest common denominator dollar cost
Yep.
per watt delivered, outsourcing everything, including accepting commissioning of the system by the manufacturer rather than having a third-party commissioning. Right.
And I get your concern on that, but here's the truth of it. Existing functional safety systems and commissioning systems aren't set up to look for systems like this. Like there is not a structure in the industry for looking for electronic backdoors. And I would advance that it would actually be very difficult to do that, right? Can you tell visually that this Apple Watch can talk to a satellite? You can't tell. There's no external indication of that. So you'd have to really dive into it to understand. The other issue inside of that is that every time you try and analyze something to understand if it has a backdoor or a listening device on it, you're doing it from a perspective of, but we understand technologies already exist.
Right.
So you might remember that story of the gift of the thing, the United States seal that was given to us by Russia.
Yeah.
And that thing was actually scanned for bugs and was declared clear because it had a really innovative listening device in there that was basically an early RFID system that could remotely be powered up and allow listening on conversations. And that was in place for years. And I use this example because it was actually scanned for bugs and declared to be clear because they didn't know what to look for. So I think it's actually a really tough problem to try and find these things in advance. And then when you discover they're there, it's too late.
If you could future-proof one aspect of or one component of today's energy infrastructure or architecture, what would it be?
Oh, it would definitely be the battery management system. And I'll tell you why. Because the key job of the battery management system is to prevent lithium battery fires. That is why we exist. That's our job, is to keep the batteries safe. The battery management system is subject to UL 1973 functional safety. The stuff above us is not, right? So for example, we have a 3-level battery management system. Our module BMS and our stack BMS must be certified to UL 1973. Our system BMS is not. It is not a functionally safe system because if you give a command to the stack that is outside of the operating parameters of the BMS, it will refuse to do it. If you ask for too much power, if you try and overcharge it, if you try and overheat it, the BMS will say, no, I'm not going to allow you to do that. I'm going to shut this down.
Wow.
So the same way that a battery management system, its primary job is to prevent a lithium battery fire, in the wrong hands, that same system could be used to cause a lithium battery fire.
Do you feel like we're underestimating the complexity involved in distributed energy infrastructure to scale and secure it?
Yes, because generally I'm an electioneer that's in the industry, so I understand it and I understand the risks. But generally, when I talk to people outside the industry, their eyes go wide and they're like, "Wait, what? That's what we're doing?" And when they understand the potential risk of not giving sufficient attention to supply chain security, people get really alarmed.